Okay, so far the minerals that we have been studying all have been kind of based on this assumption of IPV, which remember stands for independent private valuation. Now we want to kind of revisit some of these auctions, but now change the assumption to common value auctions, right? So what are common value auctions? Remember that these are situations where we are thinking of a setting where the bidders intend to actually resell the object, right? So in that case, what they are all concerned about is basically the value for which they'll resell the object, right? So there is a common eventual value for this object, the amount that they are going to get on resell, but this common value is not known, right? So on the basis of this, they have to kind of like make information about how much to bid, right? So each of the bidders may have some private information about the common value, which will lead to an estimate VI of this value, right? However, this value VI that is there, these are not independent, right? So there would be kind of like some relationship that would exist between the different estimates that these different players have, right? Now, you might expect that each of the individual bidders may be slightly wrong. So they may actually end up VI being above the actual true value or VI be ending up actually below the value. But this is the key point. These are the estimates are not independent for each other, right? So one very simple way of modeling this kind of story is to assume that the actual true value is V, right? Of the item, the what you can sell, and each of the bidders estimate VI is given by V plus some noise Xi, right? Where we are modeling the noise as a random number with a mean of 0, right? So on average, kind of like the mistake is 0, but you will still have this Xi component for which some of the VIs will be above V and some of the VIs will be below V, right? So this is the model about how these estimates are generated based on the common value V, which is unknown, and Xi, which is the noise, right? Okay. So suppose that, let's go back to our old example of a second price auction. Remember that we had this result that in second price auction with independent private values, it's a dominant strategy to bid their own true valuation, right? So let's see whether this result survives if we change this independent private valuation to the common value assumption, right? So a question is it still a dominant strategy for a bidder I to bid one's true value? The answer, interestingly, is that it's no longer true, right? So it's no longer the case that you should bid your own true valuation. Let's see why this is the case. So let's continue with this model with random noise, right? Where we have got the estimate VI coming from V plus Xi. And let's imagine that there are many bidders. And first, let's go with the case that they had followed our lesson from the independent private value case, and they thought the same reasoning applies. And each of them decided to bid their own true valuation, which was V plus Xi, right? So what are we going to get? So you still have this result that the winning bid receives the object. That is a result of coming from the fact that in the second price auction, you have got that the winning bid wins the object, right? So that is what we are considering. But you also kind of like learn something here, right? Which is that not only do you win the object, but that means that your estimate was actually the highest of all the estimates among the other players, right? So what that means is that because you have got these estimates coming in from the actual value plus noise, so this is telling us that the noise for you was actually the highest, right? Now, if you have got many bidders, so then in that case, from a second price auction bid, you are paying the second highest bid, but then the second highest bid is also likely to have been an overestimate, right? So intuitively, you would expect that in this case, you're going to end up losing the money on the resale, right? Relative to what you have paid. And the reason is basically because you are ending up actually overpaying for the amount that you have, right? Okay, so this phenomena actually has a name, and it goes by the name winner's curse, which you might have heard in some other context, right? And it is actually a phenomena which is kind of like very rich in the study of auctions, right? So this was first documented not by theoretically analyzing, but by actually people who were studying petroleum industry and seeing what happens when you are when you have got firms which were bidding for oil drilling rights for tracts of land. Now, why was this a common value auction case? Because this is basically, they are not interested in the land just because, they have different uses for the land. So they were interested in the land because they wanted to drill oil from the land, right? And whatever oil you are going to get, that is going to have a resale value, right? So this actually fits in with the common value assumption that we have. So what you are trying to estimate is what is the value of the oil. And now different people have different estimates, right? And if you kind of like in the second price auction, you have a situation, then basically the guy with the highest estimate is going to win, but then that guy is probably going to have estimate which is too high, right? So this kind of phenomena has been studied in other contexts as well. So when you have got different teams trying to compete for signing up players, again, there is kind of like each of the player is worth something, but different teams have different estimates, and then basically you tend to end up overpaying for this player, right? Because you are the one with the highest possible noise again, right? So it's a common phenomena that comes up over and over again, right? So what are the lessons that you should take away from this, right? So whenever you are trying to then bid in this common value auction, you should take into account this winner's curse idea, right? Which is that when you are thinking of bidding, you should think about what's the best estimate of the value of the object, not only conditional on your private estimate, but it's also, if you must take into account that, if you win the object, that also tells you something about how far off your estimate was from the true value, right? So it has to be the case that at the optimal bid, it is better to win the object than not to win the object, right? Because if you do not win the object, you are getting zero in the second price auction. But if you are winning the object, if you are overpaying, then you end up getting a negative payout, right? So that cannot be a characterization of the optimal bid. And so that is something that you have to take into account when you are thinking about what is the optimal bid, right? So again, we'll actually kind of like go through a case where we'll think about how do you kind of like formalize this insights. But the main result that you will get is that similar to the first price auction with independent private values that we had discussed, here too, basically in a common value auction, even if you have second price format being used, bidders should actually reduce their bids compared to through the valuation, right? And in fact, if you have first price auction with common value auction, then the bid should be reduced even further, right? So if you do not kind of like take these things into account, then this phenomena of winner's curse that we studied, that can actually lead to a lot of losses on part of the winning bid because of the reason that we discussed, that in a large pool of bidders, anyone who actually makes an error, right, and tends to overpay, then that person is more likely to be the winner of the auction, and therefore is going to be end up making a lot of losses, right? So this is a very important finding. And in fact, for this finding actually, and for figuring out in this kind of auctions, what is the actual way of bidding, actually a recent Nobel Prize was also awarded in economics.